Hello everyone and welcome back to my channel. Sorry I haven't uploaded in a long time because I was really busy. But anyways, today's video will be about midpoint and distance formulas. So midpoint and distance formula. And distance and formula. Okay, let's get started. So basically, before we learn about the midpoint formula, we need to know what is a midpoint. So a midpoint is basically a point. So midpoint definition. Midpoint def. So a midpoint is basically a point that is identified as the middle of a segment. Mid of segment. Okay, so this is the definition of the midpoint. Now, using this knowledge of the definition of a midpoint, we can derive the midpoint formula. So the midpoint formula states So the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So this is the x-coordinate. This is the x-coordinate, x-coordinate, and this is the y-coordinate. Okay, so using this formula, we can try to solve some problems. So let's see this formula. And say we have the points, we have 2, 5 and 6, 3. So we need to find the midpoint between these 2 points. So the first thing I would recommend doing is labeling x1, x2, and y1 and y2. So this would be x1 and this would be y1. This would be x2 and this would be y2. It doesn't matter which one you label as x1 or x2 or y1 and y2. It's easier for me to start from this side and then go left to right. So I write the first coordinate as x1 and y1 and then the second coordinate as x2, y2. Now that we have them labeled, we can plug them into the formula. So let's solve for the x-coordinate first. So we have x1 plus x2. So x1 is 2 plus x2, which is 6, and then divided by 2. So if we simplify this, we get 2 plus 6 is 8, and then divided by 2, well, 2 plus 6 is 8, and 8 divided by 2 is equal to 4. So the x-coordinate here is 4. Okay, now let's solve for the y-coordinate. The y-coordinate would be these 2 points right here. So we would do 3 plus 5 divided by 2. So 3 plus 5 is equal to 8, and 8 divided by 2 is equal to 4. So this is just a coincidence that both of the points are the same, but normally they will not be the same, or they will be different. So x-coordinate is 4, and then the y-coordinate is 4 also. So this would be the midpoint between the two. So now let me graph the points. So next, okay. So say we have let's go with, this is our coordinate plane. So right here. That looks good. And then we'll go maybe right here. That would be our coordinate plane. Okay, and let's say that this is 1. Oh, let's say that this is 1. This is 2. This is 3. This is 4. This is 5. This is 6, and so on. And then this would be 1, 2, 3, 4, 5, 6, and 7. Okay, so let's plot the points. So we have 2, 5. Okay, so to plot that, we would go 2 to the right. So that's a 1, 2 right here. And then 2, 5, right? Yeah, 5. And then we would go 5 up. So 1, 2, 3, 4, 5. So 2 and 5 up. So that's right here. This is point. And we'll label this point as point A, and this will be point B. So this would be point B. And then sorry, not point B. That would be point A. And then point B would be, what is the coordinates of point B? Point B are 6, 3. So 6 to the right, right here. And then 3 up. So 6, 3. That's right there. So 6, 3. That would be point B. Okay. So if we connect the two, that would give us our line. That is our segment right there. Okay, and our midpoint is 4, 4. So let's plot that. 4, 4 is 4, 4, right here. That is 4, 4. So if you look at it, it looks like it is a distance from here to here. It looks like it's the same. Well, we can't just assume that when we're given this. So we have to calculate these points of these two endpoints, and then we have to use the distance formula, the midpoint formula, and plug them in. So this is the midpoint formula right here. Okay. So now that we know the midpoint formula, there is another way to calculate. Another way to calculate the midpoint, which is using the distance formula. So let's go on to the distance formula. So the distance formula is a formula that is somewhat like the slope formula. So here we have, so the distance formula is distance formula. Okay. So the distance formula is basically square root of y2 minus y1. So this part is the top of the slope formula, if you notice. Squared. And that's plus, and then x2 minus x1, and that's squared. And this is the bottom part. This is the bottom part of the slope formula right here. Okay, so now that we know that, well, you might be thinking, okay, well, why can't we just cancel the square root with the squared symbols? Well, that's not how it works, because we have to exactly calculate y2 minus y1, then square it, and then exactly add it with x2 minus x1 squared, and then take the square root of that. Okay, so let's go on to a simple example. So let's say we have points like, let's go with 4, 7 and 3, 2. So those are the points we're just going to go with. They're random. So the same thing as that we did in the midpoint formula, I would do with the distance formula. I would label each coordinate. So this would be x1, this would be y1, this would be x2, and this would be y2. Okay, now that we have that down, let's plug them into the distance formula. So the distance formula would be square root so y2 minus y1, which is y2 is 2 minus 7. Let me just write that better. 7 and squared plus x2 minus x1. 3 minus 4 and then that squared. Okay, now let's just simplify this. So this will be equal to the square root of 2 minus 7, which is negative 5, squared, plus 3 minus 4, which is negative 1, and then squared. And if we simplify that more, we get square root of 25 plus 1, which is equal to the square root of 26. So this is the distance between points here, which is, this would be point A and point B. So point B. So this would be the distance between the 2 points right there, point A and point B. Square root of 26. Now, let's take the previous coordinates that we had, which are 2, 5, 6, 3. So we'll try that and find the distance of this. So 2, 5, and 6, 3. So this is point A and this is point B. Okay, let's plug them into the distance formula. Oh, but before we do that, we need to make sure that we label each coordinate. x1, y1, x2, y2. Now make sure you always do this, because it's important to be organized. So let's put them in the square root. So we get x2, y2, which is 3, minus 2, which is squared, plus x2 minus x1, which is, oh, sorry, this is actually not 2, it's 5. So 3, y2 minus y1, and then plus x2, which is 6, minus 2, squared. Simplify this, we get 3 minus 5, which is negative 2, and then that squared, plus 6 minus 2, which is 4, and then that squared. If we simplify this further, we get that is the square root of 4 plus 16, which is the square root of 20. So that is the distance between the two coordinates that we have right here. 2, 5, and 6, 3. So if we go back, the distance between the two, so the distance of this green segment right here, so the distance between segment, distance between segment AB, so AB is equal to square root of 20. Now notice how I didn't write this, the segment symbol over it, because if we write the segment symbol, we're making segment AB is equal to 20. We're assigning segment AB as like a variable, but that's not what we're trying to do. We're trying to find the measure or the distance between the 2 points. So that's why we didn't write the segment symbol over it. So that's an important thing. So the segment AB is the distance between segment AB is square root of 20, and the midpoint of AB is 4, 4. So that is the distance formula and the midpoint formula. Please don't forget to like and subscribe. If you have any questions regarding any math topic, I am here to help, and I will upload a video as soon as possible. So thank you for watching. Please don't forget to like and subscribe. Peace.